2016.
2016. So the whole technology I think is awesome because you guys are kind of using, I guess you could say like the original workers in agriculture, like using
Yeah.
bees to put what a beneficial fungicide on them, and basically they then go out and do all the quote unquote dirty work, I guess you could say. And so, what all kind of went into the development process? And I mean, I think that's awesome work with bees. So, what was that whole process like of making the technology?
Yeah, so I mean, the spark, if you will, comes from the fact that, bees only visit the flower, right?
Hmm.
So if you're thinking about pests that kind of, affect the crop through the flower, there might be pathogens. It could be also insects or bacterial diseases that come to the crop through the flower. The bees are an excellent way to deliver crop protection products to that crop, right? Because you're not spraying, if you were to spray a crop, you're spraying probably 95%, 96, 97% of the product that you're spraying doesn't land on the flower. It goes between the rows, between the
Hmm.
plants, air drift, things like that, water runoff, versus the bees that are just visiting the flower. So it starts from this realization that bees are in effect, a precision system, right?
Hmm.
Because you're only visiting the flower. So if you take that and you build out what you can get the bees to help you do, you come to the realization, well, it will be just like bees take pollen from the flower back to the hive. Why don't we just reverse that and take products from the hive to the flower, right? And so that's how the idea developed. So we started looking for products that are bee safe. Obviously, if bees are carrying it, you got to make sure that they're safe for the bees themselves, but then are geared towards delivering an effect to the crop that is associated with the flower. And so from there, you talk about developing the biological and microbial products themselves, engineering the dispenser systems that make this thing work in a user-friendly environment, and then you build a company like BBT around it.
Right. That's such a good point that you brought up that I didn't really think about. I mean, instead of like the blanket spraying, whether that's with, a crop duster or something else like a tractor, instead of
Right.
doing that, you're literally putting the beneficial fungicide on the bee and it goes directly to the flower and it goes exactly where it needs to go. And so I mean, I feel like that's a huge win sustainability wise because you're going to use a lot less pesticides in the life cycle of the plant. That's such a win-win.
Yeah, and we've actually been able to demonstrate when you compare a season-long fungicidal program, for example, on strawberries, and you compare bee vectoring compared to, a spray application, which is the current practice, we've shown that you can reduce the amount of active ingredient that's applied per acre of land to 1/200th the amount that you would if you were to spray. And and then of course you're talking about delivering a biological versus a chemical. So the benefits to kind of start compounding on top of each other. Chemicals versus biologicals versus chemicals, quantity that you have be vectoring versus spraying, and then you add a third element, which is important. I live in California, around water. I mean, our system doesn't use any water. A farmer may use 500, 1,000 gallons per acre of land just to spray crop protection products. You eliminate that completely. Our system doesn't use any water. And so you can start seeing the true value proposition of our technology that way.